What is meaning of electric dipole? Yes, what is electric dipole?
Two equal and opposites are separated by distance.
Two equal and opposite charges separated by finite distance is called electric dipole. Negative charge will give which type of potential? Positive or negative?
Negative.
Negative.
And positive charge will give
Positive.
Positive.
positive potential. If we are traveling in the direction of field, then potential increases or decreases? In the direction of field? In the direction of field, potential will decrease. Opposite, it will increase. And if there is no field, then potential will remain constant. Derive expression for electric potential at any point due to electric dipole. By single charge we got. Now due to electric dipole we want potential. So dipole means equal, opposite, charge separated by finite distance. Equal opposite charge separated by finite distance. Consider an electric dipole consisting of charge plus q minus q at point A and B respectively, separated by finite distance 2L. Let O be the center of dipole. Therefore, OA equals to OB equals to L. Let P be a point at a distance R. Let P be a point at a distance R from center O, such that line joining OP makes angle theta. Draw AP and PB. Draw AP and PB. Now, based on this, see how we can write theory. For positive charge, potential is positive. For negative charge, it is negative. Resultant potential is algebraic sum. So I can say consider an electric dipole consisting of charges plus q comma minus q situated at points A comma B separated by distance 2L. Let O be the center of dipole. Therefore, OA equals to OB. Let P be a point at a distance R from center. P be a point at distance R from center O, such that line joining OP makes angle theta with axis. Such that line joining OP makes angle theta with axis. Okay, please copy this one. Draw diagram and copy it in this. Join AP, comma. Hello, Weber.
Yes, sir.
You just started. I think if you read now, you'll understand this.
Okay, sir.
There was no college student, and that's why I kept at 11:15.
No, sir. Actually, we had college, but the class was cancelled.
Okay. This is we are deriving electric potential at any point due to electric dipole. Yes, you all have completed writing till join AP, comma PB.
Yes, Saddam.
Okay. Now, what is formula for potential due to charge Q at distance R? Potential at point P due to charge Q at distance R. Yes. No idea? 1 upon 4 pi epsilon naught Q by R. हाँ, इंटेंसिटी रहेगा तो R स्क्वायर आता है. So electric potential at point P due to charge Q at A, comma V1 equals to 1 upon 4 pi epsilon naught charge Q. Distance of charge Q from P is AP. Equation 1. Electric potential at P due to charge minus Q at A, comma V2 equals to 1 upon 4 pi epsilon naught minus Q upon PV, equation 2. So due to charge plus Q, we got answer 1 upon 4 pi epsilon naught Q by AP. Due to charge minus Q, we got potential as 1 upon 4 pi epsilon minus Q upon PV. Now, because potential is a scalar quantity, so resultant potential will be algebraic sum. So I can say as electric potential is a scalar quantity, therefore resultant potential, comma V is V1 plus V2. Now copy till this from here. So we got resultant potential V1 plus V2.
Sir, in the equation 2, it will be at P, right?
What we have written at P only, I have written electric potential
At BB.
due to charge minus Q at P. Okay. This is one of the longest chapter we are doing. Once this gets over, then chapter will be slightly of lesser length. Completed?
Yes, sir, done.
So V is V1 plus V2. I'm just substituting the value. V is V1 plus V. So V equals to 1 upon 4 pi epsilon naught Q upon AP plus 1 upon 4 pi epsilon naught minus Q upon PB. Therefore, 1 upon 4 pi epsilon naught Q in bracket 1 upon AP minus 1 upon P. Now, if I can find AP and PB value in terms of known quantity. Known quantity means theta is known, R is known, L is known, I can get required value. For this, there is small construction. I'm showing what is that small construction to get AP and PB. Draw AM, comma, BN perpendicular to OP extended up to N. So this is theta, even this angle will be theta. These are perpendiculars we have drawn, 90. Just draw this much in the diagram. Draw seg AM, comma, seg BN perpendicular to OP extended up to N. Draw diagram and write that draw seg AM BN perpendicular to OB extended up to N. I think this also you have done. Correct, huh?
Yes, sir.
See, we are saying P is point at a distance R. Actually, this dipole is small, very small as compared to distance. Like if this is dipole, very small, then point is at very large distance. So when you join this, and if I draw perpendicular, then this extra part, if you remove, then these two will become almost same. Same way when I draw perpendicular to this side, then this extra part when we add, we get this. That means this distance M to P is same as A to P, and P to N is same as B to P. This hasn't it. So by drawing perpendicular, you are removing this extra or you are adding this extra so that it becomes equal. So geometrically, we have to remember if length is very small than distance, then drawing perpendicular will remove that extra distance. That means this part AP is same as MP. So I'm writing like this. Since L is very, very small than R, then A to P distance is approximately P to M distance. Therefore, AP, I can write OP minus O to M. AP equal to OP is nothing but R. O to P, is it R? And see, this is right angle triangle. This angle is theta. This is A. This is M. This is O. This is L. So theta ka बाजू वाला side OM will become L cos theta or not? Hello?
Yes.
If this is right angle triangle, 90 degree, is called hypotenuse. तो बाजू वाला is cos or not? L cos. मालूम है ये क्या पूरा सॉल्व करूं? Cos theta is adjacent side OM upon OA. So cos theta will become OM upon L. OM is L cos theta, correct or not?
Yes, sir.
So OM is L cos theta. Also, B is approximately equal to P to N. Therefore, B is approximately equal to O to P plus O to N. And ON is also theta ka baju wala. So it will become L cos theta. OP is R. ON is L cos theta. PB. Now I got AP, PB in terms of known quantity R, L cos theta, which I will substitute in third. Simplify, I will get my answer. Copy till this, then I'm doing the end part.
Done, sir.
Okay. Now I'm just putting this R minus L, R plus L in equation 3. So from third, B is equals to 1 upon 4 pi epsilon naught Q, 1 upon AP, that is R minus L cos theta, minus PB, which is R plus L cos theta. So B equals to 1 upon 4 pi epsilon naught Q, R plus L cos theta, minus of this, when you multiply, minus R plus L cos theta upon R square, minus L square cos square theta plus R minus R will get cancelled. So Q upon 4 pi epsilon naught 2L cos theta upon R square minus L square cos square theta. But 2LQ is P, which is called as electric dipole moment. Therefore, V becomes P cos theta upon 4 pi epsilon naught R square minus L square cos theta. Since L is very small than R, L square cos square theta can be neglected in comparison with R square. Therefore, V is 1 upon 4 pi epsilon naught P cos theta upon R square. This is expression for this is expression for electric potential at any point due to electric dipole. Is it scalar quantity or vector quantity? Potential? Potential is scalar or vector? Yes, say what is potential? Scalar or vector? Vector.
Scalar.
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 अभी तो लिखा था ना पोटेंशियल इज स्केलर क्वांटिटी देयरफॉर v इज v1 plus v2. तो इसलिए इस तरह डायरेक्शन लिखने का जरूरत नहीं. इंटेंसिटी में v रो डायरेक्शन डायरेक्टेड अलोंग p ऑपोजिट टू p tan अल्फा ऐसा लिखा था ना. आउटवर्ड इनवर्ड इधर जरूरत नहीं बिकॉज इट इज अ स्केलर क्वांटिटी. नाउ कंप्लीट फ्रॉम थर्ड राइट दिस एंड कंप्लीट. So 1 upon 4 pi epsilon p cos theta upon r square due to electric dipole.
So could you explain from but is equal to वाला step?
But what?
But वाला जो step है वहां से नहीं समझा.
But 12q is p that वाला.
Yes.
ये कौन बोल रहा है बेटा?
Sajasmita.
You are present for all the lecture, then it is you will understand. Were you present when I told what is electric dipole?
No.
That's why you have not understood. No? See, product of charge and distance between them is called electric dipole moment. So 2L
Okay.
was distance between those two charges plus q minus q.
Yes.
See, arrangement of plus q minus q separated by distance 2L is called electric dipole. Okay.
Okay.
So 2LQ I wrote as P. P means electric dipole moment, which is product of charge into distance between them. So V became P cos theta upon denominator as it is 4 pi epsilon R square minus L square cos square theta. Now I think you have followed.
Yes.
Done, sir.
Okay. Two cases. Case 1, if point lies on the axis, therefore theta equals to, if point is on the axis, what is theta? This is dipole plus q minus q. Line joining negative charge and positive charge is called axis. So if point is here, what is theta? Theta मतलब है ये p मतलब minus q plus q के बीच का angle with axis. So if it here p, we told theta. इसको इधर लेके आता हूँ. What will be theta? Yes, what will be angle theta if point is on the axis?
0 degree.
Pardon? How many degree?
0 degree.
0.
0. When it is turned this way and brought here, then
180.
180. So if point is on axis, then theta can be either 0 or it can be 180 degree. Point lies on the axis, therefore theta equals to 0 degree or theta equal to 180 degree. So cos theta will be cos of 0 or cos theta will be cos of 180. Cos 0 is 1 and cos 180 is minus 1. So I get cos theta can be either plus or minus 1. Now V equals to 1 upon 4 pi epsilon naught E cos theta upon R square. Therefore, V at axis will become 1 upon 4 pi epsilon naught E cos theta is either plus or minus 1 upon R square. So V at axis is 1 upon 4 pi epsilon naught P upon R square plus or minus. Because 1 into anything is same thing. So it is plus or minus 1 upon 4 pi epsilon naught P upon R square. Copy.
Done, sir.
Okay. Case 2. If point P lies on equator, Equator means line passing through center and perpendicular to the axis. You can also call this as perpendicular bisector. Passing through center मतलब bisector है, perpendicular so perpendicular bisector. Sometimes they can say point is equidistant from the charge. उसका ही मतलब it is perpendicular bisector or equator. So if point lies on equator, we have to find what is electric potential at that point. So I can say therefore theta can be 90 degree or theta can be 270 degree. So cos of theta is cos 90 and cos 90 we know it is 0, or cos theta is cos 270, that is also 0. Now since V potential is 1 upon 4 pi epsilon E cos theta upon r square, so for equator it will become 1 upon 4 pi epsilon naught E upon r square, cos theta is 0. So V equator 0 into anything will become 0. That means potential at any point on equator is always 0. Right.
Thanks.
Potential surfaces. What is meaning of equi?
Equal.
Equal. And surface means any envelope or closing body which is passing through that, or we can say 1D surfaces. Surface means plane. So if I want potential is same, तो एक तो गिवन चार्ज से सेम डिस्टेंस पे रहना चाहिए ना, तो चार्ज भी सेम, आर भी सेम, तो पोटेंशियल हर एक पॉइंट का सेम होएगा. ये सबको मैं ज्वाइन करूं तो जो सरफेस है वो इक्वी पोटेंशियल बन जाएगा. करेक्ट है नहीं? हेलो,
Yes, sir.
Yes.
I can say an equi potential surface is that surface, this word will be used in the MCQs. Equipotential. So what is equipotential surface? It is that surface at an equipotential surface, that surface on which at every point the electric potential is same. Right, meaning of equipotential surface. An equipotential surface is that surface on which at every point electric potential is same. Written, I think this also.
Yes, sir.
Yes, sir.
We know that V equal to 1 upon 4 pi epsilon naught Q by R. If R is constant, R means distance, then V is constant. That means same. ठीक है, 2 लाइन लिख लो, because now we have to draw the diagram for equipotential surface. So if R is constant, then V will be constant.
Done, sir.
For point charge, equipotential surfaces will be concentric spherical surfaces with charge situated at center. That means if this is one sphere, charge is at center, equipotential surface. Second sphere, draw these concentric spheres.
Sir, sir,
Sir.
sir, uh, if the in the surface, the full surface is equipotential, meaning the charge distribution will also be equal throughout the surface.
Keep yourself muted first. After asking the question, mute yourself because there is a lot of noise in your background. Charge distribution is different story. Point charge is different story. If charge distributed, we have not done potential formula. Point charge, we did potential formula. So for point charge, at a distance r from all side, potential will be same. So if I join all those points together, it will look like a sphere, which is spheric surface like a sphere. If you increase the distance, again we'll get equipotential surface. But two surfaces ka potential is not same. Same surface ka it is constant. So if I consider this first surface, it will have potential suppose 5. Second surface may have 2. But throughout it is 2, 2, 2, 2, 2, 2, 2. Throughout it is 5, 5, 5, 5, 5. So these surfaces, they are called as equipotential surface. Charge distribution is something else. This is charge distributed. So this is potential near charge sphere wala concept. We did point charge at a distance r. What is potential? It is constant throughout distance r. So therefore this spherical body is called equipotential surface. Here 1, 2 represents equipotential spherical surface. Any more doubt?
No, sir.
Charge we have assumed to be at center. See, if charge is distributed on the surface throughout, then that entire surface becomes equipotential surface. If charge is uniform, then. Can I clear the diagram now?
Yes, sir.
For linear charge, the shape of equipotential surface is cylindrical. Line charge means charge is distributed in a line. That means if this is axis, here the charge is distributed. So its equipotential surface will become cylindrical. This is called linear charge, and this becomes our equipotential surface. Done?
No, sir.
Okay. So done now. Can I clear it off now?
Yes, sir.
So that work done to move charge on equipotential surface is zero. एकदम इजी है, इसको क्या प्रूव करें? Let P and Q be 2 points on equipotential surface. So can I say therefore potential of P is equals to potential of Q? Can we write like this? Hello, can we write like this?
Yes, sir.
Yes, sir.
Work done to move unit positive charge from Q to P, comma W from Q to P is Vp minus Vq, correct no? But both are equal. Can I say it is zero? Hello? Yes.
Yes.
So we can write conclusion. Thus, no work is done. ये सब MCQ के लिए statement बहुत important है. And 12th में theory wise, thus no work is done to move charge on equipotential surface. Charge on equipotential surface. Right, this much.
Sir, वो वर्क QT is equals to BQ minus PQ, वो नहीं समझा, वो कैसे आया?
अब क्वेश्चन पूछने के बाद ना म्यूट हो जाओ क्योंकि आपका आवाज बहुत आ रहा है. वर्क डन टू मूव Q टू P, ये कितना बार समझा है? टू मूव फ्रॉम A टू P, तो जैसा फील्ड का अंदर जाता है तो ये पोटेंशियल ज्यादा हो जाता है. सो VB माइनस VA इस वर्क डन टू मूव A टू B. बताया था ना उसमें उल्टा आता है करके. तो आपने अगर वर्क डन चाहिए Q टू P मूव करने के लिए, Q टू P, तो P का पोटेंशियल ज्यादा, Q का पोटेंशियल कम. हेलो, ये अगर 0.2 है, ये 0.1, तो वर्क डन 2 to 1 इज पोटेंशियल डिफरेंस 1 to 2. ऐसा नाउ फॉलो.
Yes, sir.
So whenever potential is given, work is asked A to B, then difference will be BQ. बैंक लिंक नहीं रहता है, एक बार फोन करके बोलते हैं। Yes, completed.
Yes.
Okay. First case, if dx is the small, we got work done for equipotential is 0, huh? So with that pretext, we are writing few points. If dx is the small distance over equipotential surface through which, that means if this is equipotential surface, dx is small distance through which unit positive charge is moved, then I can say dw, which is actually f bar dot dx bar for unit charge. dw will be e bar because q is 1. See, f is eq, q is 1, so it will become e bar dot dx bar. Therefore dw, we are telling moved on the same surface, is 0. So 0 equals to e bar dot dx bar. Any doubt till this? Because very important part we are going to write now. On equipotential surface, if unit charge is moved, work done is force into displacement, force is intensity into q, q is 1 into dx. But work done is 0 on unit positive charge. So can I say therefore 0 is e dx cos theta? What will be then cos theta? Hello?
0.
Yes. That means what is theta? 90 degree?
90 degree.
Theta 90 degree matlab intensity E is perpendicular to displacement dx bar. Correct?
Yes,
Yes,
sir.
sir.
Okay. Copy, then I'm drawing diagram to show you meaning of this. That means whenever electric field and displacement are perpendicular, work done will become 0.
Done, sir.
Thus, electric field intensity E bar is always normal to the equipotential surface. Electric field intensity is always normal to the equipotential surface. So if this is a point P, this is the field passing from charge Q, and this is one surface which is equipotential surface. This arrow indicates here we have positive charge, and this surface is suppose equipotential surface. So if I consider a surface, normal to the surface is E bar, displacement is done on this surface, dx bar. Okay, clear meaning? This is equipotential surface, this one. Perpendicular to this is E bar, and along this surface is displacement. Draw diagram. Surface is perpendicular to the direction of E bar, or E bar is perpendicular to the surface. Done?
Done, sir.
Diagram of equipotential surfaces for a uniform electric field. Diagram of equipotential surface for uniform electric field. Uniform electric field is that field which has same value throughout and same direction throughout. They are represented by parallel lines which are equispaced. So I'm just drawing electric field lines equispaced. That means they are uniform. Uniform means their value is same, their direction is same at every point. So this is electric field which is uniform. Uniform means everywhere value is same. So We know electric field is perpendicular to the equipotential surface. So I can draw one surface passing through field. Now you can see for this surface field is perpendicular. So this is called equipotential surface. But because field is constant, so we have got many equipotential surfaces. Draw the diagram showing equipotential surfaces. These two planes are equipotential surface because E is perpendicular to the direction of field. Draw diagram. Only diagram can be asked. If field is uniform, draw equipotential surface.
Done.
So today we stop here.